going to introduce some standard derivatives. So the first rule to remember is that if you have a constant, such as 2 or pi or any numerical value, the derivative of that constant is equal to 0. The next derivative that we have is the derivative of a line, something of the form ax plus b. And this is actually a specific case of some of the other derivatives that we have in this review. So if we have the derivative of x, it's just 1. So the derivative of ax plus b becomes a times 1 plus 0, because b is a constant, and we're left with just a. The next derivative rule we have is the power rule. This applies as long as the value n is not equal to 0. So this even works for negative numbers and fractions. And the derivative of x to the n is n times x to the n minus 1. Our trig function derivatives are as follows. The derivative of sine is cosine, and the derivative of cosine is negative sine. Also, the derivative of tangent is secant squared of x, and the derivative of cotangent is negative cosecant squared of x. So if you look at this, it may help you to remember that the derivatives of the co-functions have a negative sign in front of them. So the derivative of cosine and cotangent end up with a negative, whereas the derivatives of sine and tangent do not have this negative sign present. The derivatives of our exponential and logarithmic functions, we have 4 rules here, but really the rules in the left column are just specific cases of the rules in the right column. So let's look at the right column first. So we have that the derivative of a to the x is a to the x times the natural log of a. So to the left of that, we have that the derivative of e to the x is just e to the x. The reason for that is that the derivative of e to the x is e to the x times the natural log of e, but the natural log of e is just 1, so it doesn't get written in this formula. A similar thing happens on the next line. So you could work out that if we had log base e, which is the natural log, on the right-hand side, it would give you what we have on the left-hand side. So what we have here is that the derivative of the natural log of x equals 1 over x. And remember, the natural log is log base e. Also, the derivative of log base a of x is 1 over x times natural log of a. In order to do a base for a logarithm, like log base a, this has to have a positive value for a. The linearity rules tell us that we can split a derivative through certain things such as a plus and minus, or move the derivative into a function if it has a constant multiplier in front. So in particular, these rules are that the derivative of the sum of 2 functions, so the derivative of f plus g, is the same as the derivative of f plus the derivative of g. Similarly, the derivative of the difference of 2 functions, like the derivative of f minus g, is the derivative of f minus the derivative of g. Third, the derivative of a product, c times f, where c is any constant, is the same thing as c times the derivative of f. The next rule we have is the product rule. Informally, we can say that the derivative is the first times the derivative of the second plus the second times the derivative of the first. More formally, the derivative of a product of functions, the derivative of f times g, is equal to g times the derivative of f plus f times the derivative of g. For example, let's look at the derivative of x squared times e to the x. So we're going to view this as a product where x squared corresponds with the f in the derivative rule, in the product rule, and e to the x corresponds with the g, the function g. So when we take the derivative, we do g times the derivative of f. So g is e to the x, and then the derivative of f is is 2x. So what we end up with is 2x times e to the x. Plus, now we take f, which is x squared, and multiply it by the derivative of g, which is e to the x. So we have x squared times e to the x. So putting that all together, that tells us that the derivative of x squared times e to the x is 2x e to the x plus x squared e to the x. Now, if you look at the write-up of these derivative rules, of the product rule in particular, you'll see that there are a couple more examples that you can go over if you feel like you need a little bit more review of the product rule. Next, we have the quotient rule. So again, informally, I think of this as low d high minus high d low over the square of what's below. I don't know if it's been presented to you in that way before, but the formal definition of the quotient rule is that if we have the derivative of a quotient of functions, something like f over g, or f of x over g of x, this is equal to a fraction, and on the top of the fraction we have the derivative of f times g minus f times the derivative of g. So this is kind of similar, like the top of this fraction is kind of similar to what we do with the product rule, except there's a minus in there. And then on the bottom of this fraction we have g squared. So an example of this is the example of taking the derivative of tangent of x. So we already saw previously in our derivative rules, the basic derivative rules for trigonometric functions, that the derivative of tangent is secant squared of x. But the way we can find that is we can think of tangent as sine over cosine. So then tangent is a quotient, and we can apply the quotient rule. So applying the quotient rule, we do the derivative of sine times cosine minus sine times the derivative of cosine, all over cosine squared. So the derivative of sine is equal to cosine. So this first term ends up being cosine times cosine, which is the same as cosine squared. And then the derivative of cosine is negative sine. So we have negative sine times negative sine, which gives us sine squared. And that is all divided by cosine squared, because that's the the denominator. So we square the denominator when we do the quotient rule. So the write-up does skip a couple steps in here, but if you recall, sine squared plus cosine squared equals 1. So that means that the numerator of this function is 1. So we have 1 over cosine squared of x, and that's just equal to secant squared of x, because the definition of secant is 1 over cosine.